So today's lesson is on how to do a derivative implicitly. So implicit differentiation. So this is used when, because I feel like half the battle is knowing when to use like what method. It is used when y is not in terms of x. So what I mean by that is usually you are given y equals or f of x equals, and then a statement with a bunch of x's in it. Y equals cosine x, y equals x cubed plus 3x. You have y equals and then a bunch of x's. If that's not the case, it is going to look like the alphabet threw up on your paper. You're just going to have x's and y's all jumbled together in a big old mess. So basically, if it looks like a disaster, that's when you need this, okay? And then this is the big thing, is chain rule. So chain rule, when you do the derivative of y, so when taking derivative of y, you are going to chain on dy dx. And you really want to write it as dy dx. Remember how there's a lot of different ways you can write derivative? We have dy dx, we have f prime, we have y prime. You really want to write dy dx so that you notice it. I always get somebody that wants to dig in their heels. No, I'm going to write y prime. Remember that there's going to be y's thrown in there as well. You will mix up your y's with your y prime. You need it to look different. So call it dy dx. I usually get asked at that point, why don't you chain on anything for x? Let's review. What's the derivative of just an x? 1. So you can write times 1 all over your paper if you want to, but I kind of recommend against that because it's going to look real cluttered. All right. That's all the notes. We're just going to practice the heck out of it. All right. Do you see how this is all jumbled? X's and Y's all over the place. All right. That's how you know you need implicit differentiation. We're still going to do it term by term. What's your derivative of 3x squared? Okay. Taking a derivative is not any different. That part's still the same. Minus. All right. The derivative of 2y squared. It would be 4y. Do you get y? 4y. And then you chain on a dy dx. Every time you do a derivative of y, you chain on. It's derivative of y with respect to x is what that is. Equals, and then derivative of x, 1. There ends the calculus. Now starts the algebra. You have to get dy dx by itself. So you are solving for dy dx. What would you do to both sides to start to try to get this by itself? Subtract 6x. So this would be 1 minus 6x. And then your last step, divide by negative 4y. So your answer is 1 minus 6x over negative 4y. If the problem looked like a disaster, your answer is going to look like a disaster. So if it looks awful, then you probably did it right. Okay? Number 7, I wanted to review writing equations. Write an equation of the line tangent for problem number 6. So the one we just did, add x equals 1. Oh, whoops. You're probably like, why'd she start with number 6? And I only just realized that I did this. I used to have something else that was part of this and I shortened it. So I got rid of numbers 1 through 5. And I forgot to renumber it. So I'm really sorry. We started with number 6. Makes you feel like you're a little bit ahead though. So it's a good thing. All right. Anyway, we're going to write an equation for this problem. So what 2 things do you need to write an equation? All right. Point and a slope. So we need 1 comma something. X is 1. We're going to get our slope. How do you get the other part of the point? Plug it in to the original one or the derivative. Good, perfect. All right, we're going to plug in x to this original part to get our point. We're going to plug in 1 for x. So 1 squared would just be 1 times 3 be 3. So we get 3 minus 2y squared equals 1. We're plugging in 1 for x. All right, and then we got to solve that. So what would you do to both sides? What would you do to all right, minus the 3? So 2y squared equals negative 2. And then divide by negative 2. That's going to give you 1. Then this is actually kind of interesting. What would be your next step? When you square root, you don't only get 1, you actually also get plus and minus 1. So there's actually going to be 2 answers. So I should have written this a little bit smaller. I'm going to erase this and write it a little bit smaller so I can put them one on top of the other. So we're going to have 1, 1 and get a slope for that. And we're going to have 1, -1 and get a slope for that. So there's actually going to be 2 answers, which is kind of cool. I forgot there was going to be 2 answers for that. So we got the points. Good. How do we get the slope? Yeah, derivative means slope. So let's do the first one. You're going to plug in 1 for x and 1 for y to this derivative. All right, so if you plug in 1 for x, that'll be 1 minus 6, so -5. And if you plug in 1 for y, that'll give you -4. And so 5/4. And then we're going to do the same thing for the other slope, only this time we're going to plug in 1 for x and -1 for y. So what would that give us? If we plug in 1 for x, we still get -5 on the top, and then over 4. Okay, so just -5/4. And then you're going to write 2 equations. So you're going to get 2 answers. So let's do the first one. It would be y minus 1, good, equals 5/4 parenthesis x minus 1. That's 1 answer. And then use the other point and the other slope for your other answer. So that would be y plus 1, good, equals -5/4 parentheses x minus 1. Cool. So we got 2 answers. That's cool. I just wanted to review writing equations so we don't forget how to do that. All right, let's try number 8. Derivative. Oh, question. Go ahead.
So
Which I've seen, by the way.
Could you get a point if you did one of them?
Yeah, typically they would, and that would be a second point for the other one. Yeah, they would each be worth 1. All right. Derivative of 5y. What do you guys think? 5 dy dx. Good. When you do a derivative of y, you chain on dy dx. Plus, okay, that next thing is x times y. That's going to be what rule? It is product rule. The first thing is x. The second thing is y. All right, so let's review product rule. How does it start? All right, the first thing, so x times derivative of the second. Derivative of y is good. Okay, cool. You guys have got that. So first times derivative of the second plus the second, which is y, times derivative of the first. Derivative of x is 1. I wrote it to show it to you, but we are at the point where if you don't want to write that 1, then fine. All right, so that's our product rule. Equals derivative of x squared is 2x. Cool. That's the end of the calculus. Now it's algebra. You need to get dy dx by itself. Now, do you see how there's 2 of them? You're going to leave those where they are. Evacuate this to the other side. So when you subtract over that y, on the right side of the equal sign, you're going to have 2x minus y. I didn't write the rest of it yet for a reason. We're going to see what we get for that. But do you see how I just moved this over? So now here's what's left. We are going to factor out a dy dx since they both have 1. So we're going to factor out dy dx. What's left when you take that out? It's like GCF. What's left? 5 plus x. Yep, I knew what you meant. And then to get dy dx by itself, you would divide by 5 plus x. So your final answer is 2x minus y over 5 plus x. And again, the problem was a disaster, so the answer is probably going to be a disaster as well. And it's heavy on the algebra, so you got to be really organized and careful and work slowly, okay? And it's going to look awful. You just have to accept that. Oh, Trey, what rule do you need for this? Chain rule. It's like sine got hungry and ate 4x squared. All right, what's the derivative of sine? Cosine. So you would have cosine 4x squared. Now I'm gonna write it out front so that it's more like a coefficient. You can times it at the end, but it's gonna be really messy. You would chain on the derivative of 4x squared, which is 8x. So I would just recommend putting it out front. Good. Minus, all right, now that's another chain rule. What's your derivative of cosine? Okay, so it would be minus negative, so it would be plus, leave a little gap there. Sine of 5y, because when I chain it on, I'm just going to write it out front instead. You have to chain on the derivative of the inside. So derivative of 5y. Good job, guys. Nice. All right. Equals. Why is it 0? Constant. Good. But equals 9 is a very, very common mistake. So common that they will make that one of the wrong answer choices. It happens all the time. So if you do that, don't beat yourself up, but try to remember to put 0. All right, now we need to get dy dx by itself. We have to kind of like unbury that. So algebra, you would move this to the other side. So you're going to subtract over all of that, like that stuff. So it would be negative when it gets to the other side. Now you're left with this. You would divide by what? 5. You would divide by everything that's not the dy dx. Do you get what I'm saying? Okay. So you're going to divide by 5 sine of 5y, and that will get your dy dx by itself. I honestly recommend doing as much as possible in your head. And I know I almost never say that. I'm like, show all your work. But here's the thing with these. They're so messy that the more times you copy it over, the more likely it is you're going to do a copy error. So I actually recommend writing as little as possible for these, and try to hold as much of it as you can in your head, because the more times you copy, the more likely it is you're going to have a mistake. All right. I think I tried to do like every rule in here to review them all. So here we got E. Derivative of 5e to the y is 5e to the y. Chain rule, dy dx.
So it's not with
5's just a coefficient. It's just there.
Oh, it was like another time.
Oh, if the 5 was up there with the y, then we'd have to do that. But the 5 is just kind of sitting out front. Okay. Plus derivative of 3x is just 3 equals dy dx. Perfect. Nice job, guys. Now, the algebra for this one's going to be a little bit tougher, because do you see how there's 2 dy dx's? The first thing you have to do is get them on the same side. So we're going to subtract over this whole thing. So we're going to get 3 equals dy dx minus 5e to the y dy dx. So you have to subtract that stuff to the other side. And then when there's 2 of them, you have to factor. So you're going to factor out its GCF because they both have it. And then that's extra tricky. What would you be left with when you factor that out? Good. 1 minus 5e to the y. Perfect. And then your last step would be what? Divide by that stuff, like everything that's not dy dx. So it'd be 3 over 1 minus 5e to the y equals dy dx.
For any of these, if we're able to simplify.
Don't.
Okay.
Now, if it's multiple choice, you'll have to still be able to figure out if it simplifies to A, B, C, or D. But essentially, and I think number 12, I am going to simplify because I want to show you that. But free response, don't touch them. All right. X to the 4th. What's your derivative for x to the 4th? All right. 4x cubed plus, the 10 is just there. Just 10 is a coefficient. Your derivative of ln of y, 1 over y. So I'm going to write 10 over y times dy dx. Good.
So does that ever change? Like, if we're to have like a weird derivative or something, it's always gonna be dy.
Derivative of y is dy dx. It's derivative of y with respect to x. Now, we are going to do some next time where we change the letter of the alphabet. and it won't be y and x anymore, but the concept does not change. Okay. Plus derivative of y squared. Good. 2y dy dx equals derivative of 0 is 0. Constant. Now, do you see how there's two dy dx's? They're on the same side though. That's good. Leave them where they are. The first thing we would move over is the 4x cubed. So you would subtract that over. And then from everything else that's left, you're going to factor out a dy dx. And so that would leave you with 10 over y plus 2y. And then all of that gets divided to the other side. So this is kind of what we were just talking about up here. I think some of you were listening. If it's free response, I want you to leave it like that. But if it's multiple choice, they're not going to leave a fraction in a fraction. So I'm going to show you how to fix it. You would multiply all three of these terms by y, and that would cancel that out. So you'd multiply this by y, multiply this by y, multiply this by y. Let me just show it to you for the sake of being thorough, because we don't have a lot going on today. So that would give you negative 4x cubed y. And then what would this turn into down here? If you multiply them both by y. Okay, good. Your algebra skills are very good. Oh, actually, they would do one other thing though. Do you see how there's 4, 10, and 2? You can divide them all by 2 and reduce the fraction. So it'd actually be negative 2x cubed y over 5 plus y squared. I'm bringing it up. Most of you are just staring at me now. I'm bringing it up because I don't want you to do the problem correctly and not be able to pick the correct answer. Okay. One more. Stick with me. We're not doing a break because this is real short. What does this mean? Second derivative. Okay, well, you got to do the first derivative first. All right. Derivative of y cubed. 3y squared dy dx. Good. Equals derivative of x squared 2x. I almost just said the answer. And then to get dy dx by itself, you're just going to divide. So that's your first derivative. Now, when you go to do a second derivative, I'm just going to start over here. Because that's a fraction, because we're doing the derivative of the derivative, what rule would you need? And I think I tried to fit every single rule we did. I think I got all of them. All right, so how does quotient rule start? The bottom. Okay, denominator, 3y squared times derivative of the numerator should be 2, good, minus 2x. Derivative of 3y squared would be 6y dy dx over denominator squared. We're not done. We're not even close. So don't stop listening to me. I hope you're writing with pencil. If you're not, you're going to have to scribble this out. You're going to need to erase dy dx and replace it with what dy dx equals, which is that 2x over 3y squared. So we erased dy dx, we replaced it with what dy dx equals. Now we're going to do a whole ton of cleanup here, make it look prettier. What is this first term going to be? Yep, 6y squared, good, minus, oh goodness, let's see, 2 times 6, let's do all the numbers first. 2 times 6, 12 times 2 is 24, divided by 3 is 8. So our coefficient is 8. X times x, x squared. And then we have a y, but then divided by a y squared. So it's just 1 y, but it goes underneath. So one of the y's canceled, one of them stayed, but it was underneath. And then that's over 9, good, perfect, y to the 4th. Again, I'm going to show you how to fix that, because if it's multiple choice, they're not going to leave a fraction in a fraction. We're going to do the same thing we did in the other one. You're just going to multiply everything by y. So what would that give you? This would be like your final answer. If you multiply them all by y, this would be 6y cubed minus 8x squared over 9y to the fifth. You got, my pep talk is you just got to be able to do the algebra because I don't want you to get the answer right and not be able to pick your multiple choice.